Imagine looking into a window that doesn't show the present, but reveals the distant past. Every beam of light collected by the James Webb Space Telescope has traveled across space for billions of years before finally reaching its golden mirrors. That means every observation is a glimpse into cosmic history, allowing us to witness events that happened long before Earth, the Sun, or even our own galaxy reached their current form. Unlike ordinary telescopes, Webb was designed for one extraordinary purpose: to explore the earliest chapters of the universe. Its powerful infrared instruments can detect ancient light stretched by the expansion of space, revealing objects too faint and too distant for previous observatories. According to modern cosmology, the universe began roughly 13.8 billion years ago with the Big Bang. During its first moments, temperatures were unimaginably high. As space expanded, matter slowly cooled, allowing hydrogen and helium to become the dominant elements filling the young cosmos. For millions of years, no stars illuminated the darkness. Astronomers call this period the cosmic dark ages. Gravity gradually pulled enormous clouds of gas together until the first stars finally ignited, ending one of the quietest eras in cosmic history. Those first stars were expected to begin a slow process of building galaxies. Scientists believed the earliest galaxies would be small, irregular, and unstable, taking billions of years to evolve into the magnificent spiral and elliptical galaxies we observe today. That expectation remained largely unchallenged until the James Webb Space Telescope began returning its first deep space observations. As Webb examined tiny regions of the sky, areas that appeared nearly empty in earlier images suddenly became crowded with ancient galaxies. Instead of finding only primitive systems, astronomers discovered surprisingly bright, massive, and well-organized galaxies that appeared far earlier than expected. Some displayed rotating disk-like structures. Others contained dense central regions packed with stars. Several looked far more mature than computer models had predicted for such an early stage of cosmic history. Initially, researchers questioned whether the distance measurements were accurate. Since astronomers estimate cosmic distances using redshift, any error could dramatically change the age of these galaxies. However, additional observations repeatedly confirmed the same remarkable conclusion. Many of these galaxies truly existed only a few 100 million years after the Big Bang. In cosmic terms, that is an incredibly short time. It is almost like discovering a modern city where only the first foundations should have existed. The surprises continued when scientists analyzed the light emitted by these ancient galaxies. Light acts like a cosmic fingerprint. By separating it into different wavelengths, astronomers can identify the chemical elements present inside distant objects. What Webb revealed was unexpected. These galaxies already contained elements such as carbon, oxygen, and nitrogen. These heavier elements are created inside stars through nuclear fusion before being released into space when massive stars end their lives. Finding them so early suggests that stars formed, evolved, and died much faster than many theories had anticipated. Rather than a slow and peaceful beginning, the early universe may have experienced an intense burst of activity, with generations of stars rapidly enriching space with new elements. If these observations continue to hold true, scientists may need to revise long-standing models describing how the first galaxies formed and evolved. And this was only the beginning of Webb's discoveries. Because another mystery soon emerged, one involving some of the most extreme objects in the universe. The surprises did not end with ancient galaxies. As astronomers continued analyzing Webb's observations, another mystery began to emerge, one involving the most powerful objects ever discovered in the universe. At the center of many galaxies lies a supermassive black hole. Some contain millions of times the Sun's mass, others contain billions. For decades, scientists believed these giants slowly grew by consuming gas, dust, stars, and occasionally merging with other black holes over billions of years. But James Webb found evidence suggesting that some enormous black holes already existed when the universe was still incredibly young. That raises an extraordinary question. How could something so massive grow in such a short amount of time? Researchers have proposed several possibilities. Perhaps some black holes formed directly from collapsing clouds of gas instead of first becoming ordinary stars. Another idea suggests repeated mergers happened much faster than expected. There are even theories that unknown processes involving dark matter may have influenced their rapid growth. At the moment, none of these ideas has been confirmed. Each new observation provides another piece of the puzzle, but the complete picture remains out of reach. The mysteries extend beyond black holes. When Webb observed some of the earliest galaxies, astronomers expected to see chaotic collections of stars still taking shape. Instead, many appeared surprisingly organized. Several displayed smooth rotating disks. Others showed bright central bulges surrounded by structured stellar populations. Such orderly systems were not expected to exist so soon after the birth of the universe. These observations suggest that galaxy formation may have progressed far more efficiently than previous computer simulations predicted. Invisible dark matter could play an important role. Although it cannot be seen directly, dark matter makes up most of the universe's total matter. Its gravity provides the framework around which galaxies are thought to form. If dark matter behaved differently during the universe's earliest history, it could explain why galaxies developed much earlier than expected. Webb has also transformed our understanding of cosmic chemistry. Using infrared spectroscopy, the telescope can identify molecules floating between the stars. Among its discoveries are complex carbon-rich compounds found inside distant clouds of gas and dust. These molecules are considered important ingredients in the chemistry that eventually leads to planets and, potentially, life. Their presence across enormous distances suggests that the basic building blocks of life may have been widespread throughout the universe for billions of years. This does not prove that life exists elsewhere. However, it shows that the necessary chemical ingredients formed remarkably early in cosmic history. That possibility has profound implications. It means the conditions required for life may not be unique to our own solar system. Perhaps countless worlds have inherited the same chemical foundation. Every new observation reminds us that the universe is more complex than we imagined. Rather than confirming every prediction, James Webb continues revealing phenomena that challenge long-standing theories. Instead of providing all the answers, it is uncovering entirely new questions. That is how science moves forward. Every unexpected discovery forces researchers to improve their models, test new ideas, and explore possibilities that once seemed impossible. The James Webb Space Telescope is more than an observatory. It is humanity's attempt to read the oldest surviving chapters of cosmic history. Every photon it captures began its journey billions of years ago, crossing an expanding universe before finally reaching Earth's most powerful space telescope. Those ancient signals carry stories from an era when the first stars ignited, the first galaxies assembled, and the foundations of everything we see today were being created. The deeper James Webb explores, the clearer one truth becomes. The universe still holds countless secrets. And with every new image, every spectrum, and every distant galaxy, we move one step closer to understanding where we came from, and how much of the cosmic story has yet to be discovered.